How's it going, everyone? Welcome. Oliver Gonzalez here. And we'll continue to look at this particular chapter from the book You Don't Know JS Yet, made by Kyle Simpson, a software engineer with over 20 years of experience, where I agree when he just mentioned that if you want to be a competent JavaScript developer, the next level is to understand now how your tool works behind the scenes. So in the first chapter, we look at what is JavaScript, who made that, what was the plot behind the name, what was their target audience, in who actually owns the trademark of JavaScript, as well as the people that oversee the technical spec known as the TC39. And despite how do you name this, whether it's ECMAScript or ES in the year of the spec or JavaScript, all of them are the same, right? So we also looked at this particular group, the TC39. So they meet every month, bi-monthly, and in there they are deciding which proposal or champions actually weigh it is all the way up to the top by passing through this series of a stage from 0 to 4 to actually be now implemented by the JavaScript interpreter or by the JavaScript engines, right? So because the group doesn't know the reality of the web, and the JavaScript engines actually have to deal with that. Sometimes they want to, or they actively refuse to follow certain spec, and then you can find is that in a particular appendix on their spec, right? Where they describe in a certain environments, due to legacy reasons, they now behave in this particular way. However, and sometimes the TC39 actually is have to go back and redraw or refine the proposals. A good example of that is this Mushgate. I don't want to dive deep into this, but it's quite interesting if you are if you want to go into this, which the TC39 have to go back, refine the proposal so they can now be accepted by the reality of the web. And because of this mismatch that exists, which is something that happened a lot of as a JavaScript developers, I was one of them, and I tried to understand how this tool actually works, is by this different environment that we can execute JavaScript, whether it is on the browser, on the server, light bulbs or robots. Each one of them provide a certain set of rules or APIs that we can interact with. So for example, in the case of browsers, so get current location, get user media, or fetch, or console or alert, unlike the server when you can actually have and read and write files and so on and so forth, right? So, but the point of this is that despite this huge or this variety of environment that can exist or that exists, the only reality that matter is in the web, right? And especially because we are using these dev tools, and this particularly console that you look at, this is not a truthy or a strict JavaScript. It doesn't follow the strict JavaScript implementations. So for example, it's like when you put now things like strict, which behave different in how actually works for JavaScript engine and how they actually interpret that. The point of this is that this kind of environments, they are JavaScript friendly. So for example, is when you're using the strict mode, this strict mode only lasts is for the season. Where in contrast, when you analyze your, or when JavaScript analyze the engine look for a use strict, it does that per file or per function, right? And the idea of this is to also look, for example, is how, for example, in here in this console, uh, when you now add some variables or functions, it go and add those to the global scope, all right? So you can have access to this. Where the reality is that this is not what happened in a JavaScript file, you know? And all these subtle things that happen here is just as a way to understand that each one of those environments has their own, even though that they must follow the spec, not all of them stick to that, and it's important to understand that. So what does it mean is that the there are several environments that allow us is to do some specific stuff. And for example, the dev tool, this is a friendly environment, and since the TC39 they don't want to break their web, they actually is now provide this backward compatibility, unlike HTML or CSS, where they are forward compatible. So because of this, we have now, for example, shims or polyfills that allow us as a JavaScript developers to use the Lyric syntax while providing backward compatibility for features that some browser doesn't support, right? So these features are provided by the community or sometimes by the official libraries, you know. But the idea of this is to also look and understand how the JavaScript engine actually works truly, because in essence JavaScript is a compiled language, and most people have mixed feeling about this because a compiled language is something that it analyzes the entire file for any errors, and then it creates now an abstract syntax tree, which is a map that allows to identify which is the information that is going to be used for the language to actually translate that into instructions for the machine, which is usually generate this as a binary portable program ready to be executed in that distro, right? Whether it's on Windows, or whether it's on Mac, whether it's on iPad or Android, you name it. And each one of them has their own file extension. It's just to identify as this file. Useful when you want to send that over the cable, when you want to transmit this binary files. So you receive that, followed by the extension, and now you can understand what the receiver sends you, despite that it receive all of these zeros and one. So because of this, right, and since JavaScript, the debate is that the history of the language is that, hey, this language here, or any interpreted language, is per se an inefficient and not so performant language like a compiled one, all right? So, but the point of this JavaScript language is because the nature of the web, which is not synchronous. You have to wait for things to be loaded, especially if you want to provide some interactivity and so on and so forth. So, do this nature, and the heart of this question, if that is JavaScript an interpreter of a compile, is the way how it handles errors. So, when you in JavaScript, when you wrote a JavaScript files, and when your file leaves the ID, it's going to be transformed into it's going to be transpiled into a specific version of JavaScript that can be widely accepted by any JavaScript engine out there, all right? Usually browsers, that is passed through a Babel, right? And then it's gonna pass through a build process, all right, as a way to bundle up that ready to be delivered. So when your JavaScript engine receives that, it's going to now parse this, and after that, it's going to create a nested syntax tree that generate is an intermediary binary representation of code known as bytecode that inside of the JavaScript engine, depending on the implementation specific, is going to take that code and perform some further optimizations until your code is ready to be executed by the engine. So all of this series of steps that happen here is just a way to be able to describe what JavaScript is, and I am not making this up. You can actually check that when you do some syntax error, all right, which is in essence the parsing methods or the parsing way. So I don't want to dive too much into the compiler theory, but the compiler theory summarizes that first you need to tokenize all of these operators, identifiers, keywords, to actually put them in a particular bucket, all right? So with all of this information in all of those buckets, now it is ready for creating is the abstract syntax tree, this map about the programmed execution or the program instructions that then is going to now is generate all of that into a portable binary executable. So the point of this is that JavaScript at the end of the day is, if it's not in essence, JavaScript in essence, if it's not in practice, is a compile language. So far so good. Good, no problem with that. Now, then I look at the nature of the concern about the language, that this language can be quite slow. So for example, in terms of parsing and executing, so there has been some milestones to first determine that JavaScript, in fact, it is fast enough with the ASM.js, which is a subset of JavaScript that is not intended for us to be author, right, or to write this, to author it. But the point is that by providing now some hints to the JavaScript engines, we can now, or at least the Mozilla developers back then in 2013, where they actually now is dedicate to test that, and they pour now an Unreal game engine to the browser at full 60 FPS, which is a great stuff, which is great. It actually shows that. So the WebAssembly, which is this spiritual successors, it takes now things a little bit further by skipping is the parsing phase, all right? And it has now this intermediate representation that looks like assembly, where by skipping the parsing is now going straight forward to the execution phase in the JavaScript engine. So this WebAssembly has become as the universal compiler target, because you can tell a particular compiler to output into WASP, all right? Whether it's to Rust, to WASP, or Java, or JavaScript, so on and so forth, all of this to pour into that. And from there, you say, okay, now I want to execute that in any WASP environment, which is something that is quite pioneer, and I think that for example, Netflix is actually using that when it comes to deliver JavaScript. So, but in any case, the point of this is a course of JavaScript, and understand is the JavaScript as well as the other uh, things that are more relevant, which is the strict mode, right? So strict mode is just guidelines to developers to help us write the code to have a better chance for the JavaScript engines to optimize and run our code. For doing optimizations and executing our code as fast as possible. So this is the kind of um, executions that we want to do here, or that the strict mode actually enforce us. It also changes the semantics, and because what we really care in today's video is the chapter 2, which is okay, now let's go into serving is the JavaScript. Okay, so how do you know well about this? And first thing first is understand that each file is a program, which can be quite counterintuitive because when you ship your entire applications, you might feel the temptation to think that the engine is processing the entire program as one, where the reality is that if you have multiple standalone files, each one of them is a own program. So if you want to recap about the OS theory here, which is, well, at the end of the day, a program is a set of instructions that sits on normally, right? It's a set of instruction that, and by normally I mean is in compiled language, all right? So a program is this portable binary executable that is ready to be, it is portable binary executable that sits on your disk, and and when you click on that, it is loaded into the main memory, and the OS call the processor that effectively are creating now a process. And this process, where you have inside of them is threads, where this or a particular characteristic of the process is that you have a separate so a feature of a process is that it run in an isolation, so one misbehaving process won't interfere with other processes. So this is great. For example, and a good example is Chrome, where you can define each one of those tabs as their own process, and one misbehaving tab won't crash the other tabs. So a good example of processes is like the program counter, which indicate that which line it is currently the program execution, or the stack, or the register counters, the register processors, okay, and each one of them, the reality is that it lives now inside of something called a thread, and a thread is a single unit of execution that is defined by the OS to pass now workload to the process. And because this process of switching in and back, switching in and out threads or processes, all right, is known as context switching. So because context switching is a very expensive things to do, because especially in process, since it now have to keep track is the state of the application as well as the memory, the virtual memory, and some internal representation of the kernel, this is not that expensive in the case of the threads, since these threads live inside of the process and they share now the heap or the memory. Okay, so this context switching, because it's so expensive, now they have some alternative like fiber and coroutines. When the application where the switching or the concurrency is handled now at the application level. It's a responsibility from the application developer to periodically or to deal the control, the flow control, and manage that when they see fit in your program. So this now is just to describe is what is a process, what is a thread, and the different pieces involved in the OS. So for example is the context switching, and now the alternative that we're looking here known as fibers and coroutines. And so for example, when you're dealing with this concurrency, for example in promise, now and you want to deal with series of eventual values or series of concurring events that can happen. Now coroutine is something that is being used, for example, in language like Go. So in any case, this is just to make a quick recap of this, that each program now acts as a single one. Each one of those programs, the only way that they now works like a single program if is each one of those standalone programs share the state via the global state, or by sharing is the methods or states and exposing them publicly. All right, so for example EX6, when you have now models, when you import or you use the script type models, when you, for example, use the import or the script tag model, since each one of those files are their own files, due the loading mechanism, they now at runtimes behave like a single program, because now they are actually calling and parsing this or linking all of these different files. So the thing here is that at runtime, all of these different models are now interoperable in each one of them. But the point of this is that think of each one of your files as each programs, regardless the co-organization, which is a model, all right, or it's type model, regardless of co-organizations or loading a mechanism, think of all of your file as a single program, right? So this is something that I wasn't well aware, all right? And then when we move now to understand the values, which is what we are currently right now, what we are to understand is values like this, all right? So values is the most important unit of information. So values are data, and it is how your program maintain the state. So because in JavaScript we have now primitive and objects, and the way how can we maintain the state is by using each one of them. So you have now a string, which is a collections of characters, right? Where you can access to this, index to that, and whether you're using single quote or double quotes, you should now stay and stick to yeah, you should now stay and stick to the yeah, I have a regulable yeah, I do have a regulable desktop here, and I love it, man. Definitely, I do. There you got it. All right, good. So now this is values, and so since values allow us is to so allow programs, or is the way how programs maintain the state of the applications. So values here we have several type of them. We have several types to maintain the state of the application, to represent those that, right? So we have now a string. Hey, we want us to now maintain the state of the application like this, by showing us this, right? I want to now maintain the state of this portion with this character, with this string, with this sequence, right? And we also, later on, we're gonna see this particular sequence, where this sequence is follow is a particularly standard, a particularly particularly format, right? Of how can we represent is then, all right? We have the basic multilingual, and then the astral plane. Again, this is just a way of this is just labels of the Unicode, which is the way of how you can represent strings, characters that points to specific sequence of numbers, right? Zeros and one, binary. So string is one of them. We also look at how can we use a string with string interpolation. We also look at the numbers and booleans, right? Again, values that can or the values that are the unit of information. And I stop here on the unit of information because when you tell or when you ask yourself who defined this, who defined what is a unit of information, right? So that's when you go down into the rabbit hole and say, well, at the end of the day, it was Sean Claw, which is considered the father of information theory, that using the mathematical principles, it say, hey, this is how we're going to now provide structure to the way of, this is how we are going to quantify its information. That's pretty mind-blowing stuff. That's pretty mind-blowing stuff, if you might guess. You think? So this quantification is now makes it's making it much more tangible. It's making it much more digestible, easy to go and easy to use. And especially here to represent is how much this information weighs. All right. So whether it's 4K and 8K and so on and so forth. And this is something that can sound even esoteric or mystic about, But now, since we are in this era of information, it is something that is quite obvious. So we are now in the same air that we breathe. So because we are in this era, because we are in this air that we breathe, we give by settle a lot of things to do. And one of them is the unit of information and what it represents that. And how programs actually use that is to maintain the state. So strings, booleans, numbers, uh, and how now numbers is also follow particularly a spec that whoever language that use this actually is going to fall into some of the common gotchas. So, for example, is the limitations to accurately represent is numbers. So, in this limitation is because, for example, when you want to divide 1 by 3, all right, because there is no finite way to represent or to store this to store that, right? So it's like trying to put an oak uh, inside of a basket, right? You try to put the entire oak inside of a basket. And you might think it's like, why will you want to do that? Well, because this is the limitation that we're facing right now, right? This is the basket that I have. This is the capacity that I have right now, you know. So it's pretty much like you're trying to carry an oak with your two hands or your two arms. I mean, perhaps sometimes in the future we might, but right now we can't. And this is the limitation exactly what happened in the computers, right? They have now finite memory space. And because of that, well, we need to store somehow at least to represent something. So because those language that follow the IEEE 7054 spec that describe is how the numbers is going to be represented, whether it's using a 32 bits or 64 or 128 and so on and so forth. So one bit is represented by the sign, a portion is represented by the exponent, and the other is by the mantissa, where they can now express is in whole numbers or fractions. And again, because of this inability to store accurately numbers, long numbers, so we have to do this, right? So this is something that we're gonna see that later on, and understand that 1.1 plus 1.2 is actually give you this, all right? And how now, for example, so, but in any case, but in any case, exactly. So we move on, right? This is number, while false, yada yada yada, mat pyth, And we also look at that the null, right, as a way to describe is emptiness. Why it's important to use is um, yeah, why it's important to use is yeah, why it's important to use is undefined rather than null, because well, undefined is when it comes to take the type of this value, all right, or the yeah, when it comes to determining the value of a type, unfortunately with nulls you get is object, and this is for historical purpose, where the language in itself actually in an attempt to identify is what is a primitive and what is a value. Undefined, it represents now the absence of a value in a primitive, whereas now null represent is the absence of a variable in an object, in a reference in memory. So that's why it returns now an object. But in any case, so yeah, it also is the symbol, which is used for store secret data that is being used, for example, in low-level libraries or framework. I am not quite familiar with this, which is something that we might have to look at later on. So arrays and objects. So arrays, all right, at the end of the day, they are just now a special kind of objects, and objects is the other type of values that we can have to represent is the another value that we have in the language, where now programs can use to maintain the state. In this case, hey, I want to represent is this, for example, is this. I want to represent is this in a tree-like structure or in an object-like structure, right? So, because in array, this is a collections of is a numerically indexed collections of values, whether it's primitive and objects, and also can hold is arrays, right? It also can, something that we're gonna see later, is functions, right? And when you talk about this value determination, which is using now type of to describe and to get that value, all right? Again, now we're finally getting to the specific of the language, all right? To have a more practical sense, when you want to determine is the value of when you want to determine is the value, we use now type of, which return us is a string to do so. And this is why we need to, well, use, for example, is undefined instead of null. And another is that when you use that for function, it returns now a functions. But when you want to check now an array, it actually return now is an object, because array are a special kind of objects. Okay, so we're gonna see that how can we now look at that. What are the methods to that? And when you want to know how to convert one value to another, this is known as type coercion, or an abstract syntax operation, an abstract operation, which is a series of steps, is an algorithm that is defined in this spec to decide, hey, how we going to now coerce or transform these two values when we find them, right? So for example, in double equal or in triple equal, right? Or in a comparison, in exactly. So this is how you can transform from one value to another. the type coercion, right? And the other is that later on we're gonna see how to how uh, how the behaviors of primitive and objects change when they are assigned interest, when they are assigned or passed to them, right? So that makes a lot of sense. And here we are. Good. Now, and then we look at declaring and using variables. Here we are. So to be explicit about something that may not have been obvious in the previous section, in JavaScript programs, value can either appear as literal value or they can be held in variables. Think of variables as just container for values. And variable has to be declared or created to be used. And this is now talking about declaring and using variables. This might sound quite silly, but it's important, especially if you're going to build a particular product, right? If you're gonna build a product, you need to understand. It is quite easy to understand this because it is already there. You don't have to think about this. You just only have to follow the recipe, similar like you do, for example, if you're building a Millennium Falcon. I think it is. Millennium Falcon, I think it is. The Millennium Falcon Lego, right? You just follow the instruction, and this is exactly the thing it is. You know? So is this, right? So values can be used literals, okay? They can appear as literal. So for example, what I'm describing here, this is a literal, it's a numbers literal, or they can be held in variables. And think of variables as a container of that, right? And there are various syntax that can forms, okay? Or there are various syntax forms that declares variables, that declare these containers of this, aka identifier. And each form has a different implied behaviors. So this container, which is the way of how you can store is, or what you can now held, is values, all right, that you can in the languages have express variables as literal or held in the variables, which is a container. And this variable that can be declared or created, right? They can be declared or created. So you have a specific syntax to declare that they behave differently. Okay, so they have any different implied behaviors. So for example, like var has a different implied behaviors to define these variables, to define this container of values. Okay. So for example, var, okay, is a function, exactly. var, like this, the var keyword declare a variable to be used in the part of the program and optionally allow an initial assignment of a value. Another similar keyword is let. The let keyword has some difference to var, with most obvious being the let allows a more limited access to the variable than var. This is called block scoping, as opposed to regular function scoping. So these functions, this regular function scoping like var, where they allow you to define is this container of values, right? And those values are the way how you can maintain the state of a program here, okay? To represent something. Now, let is a more constrained scope about this. This is called block scoping, as opposed to regular function scoping. So the attempt to access age outside of the if statement results in an error because age was block scope to the if, whereas my name was not. Is now functional or regular scoping. So block scoping is very useful for limiting how widespread variables declarations are in our programs, which help prevent accidental overlaps of their names. But var is still useful in that it communicates these variables will be seen by a wider scope of the whole function. Both declaration forms can be expressed in any given part of the programs, depending of the circumstances. Depending of the circumstances. So it is very common to suggest that var should be avoided in favor of let or const, and generally because of perceived confusion over how scoping behavior of var has worked since the beginning of JavaScript. I believe this is to be very restrictive advice and ultimately unhelpful. It is assuming that you are unable to learn and use the feature properly in combination with other features. I believe you can and should learn any feature available and use them when appropriate. And here we're talking about is the assignment and the using of variables. And the assignment of values, declaring and using variables. So a third declaration form is const. It is like let, but has an additional limitation that it must be given a value at the moment it is declared, and cannot be reassigned a different value later. So for example, like this, you have now the const, you have now the age, right? So const, it is similar to let, but has additional limitation or additional constraints of that you must provide is a value at the moment that is declared and cannot be reassigned. And cannot be reassigned here. So for example, like this. So if you're trying to have birthday, it will throw now an error. So for example, if we run this piece of code, right? So how do we know that this because if the JavaScript engine, all right, if the JavaScript engine it will now evaluate. So for example, it will say something like this. So if JavaScript is a interpreted language, or depend of this phase when this error is doing, I think this will be done is at the runtime error. So in other words, it's going to show the 39, and then it's going to see that assignment to constant variable is not possible. However, when we do something like this, all right, and then we say something like this, name, right, is not going to even process this. So syntax error is not even process this. Invalid or unexpected token here. And the problem is what's this. Unfortunately, it doesn't tell you at which line, but but the parsing actually identified that, hey, there was an error, to tell you. Again, this is a friendly JavaScript environment. Okay. So the my birthday constant is not allowed to be a resign. Consts declare variables are not unchangeable. They just cannot be reassigned, and it is ill-advised to use consts with object values. and yes, and it is ill-advised, man. And it is ill-advised. And it is ill-advised, man.
Antes de comenzar con el curso, vamos a conocer a...
Exactly, and it is ill-advised to use counts with object values because those values can still be changed even though the values can be reassigned. This leads to potential confusions down the line, so I think it is wise to avoid situations like this, where you can, of course, modify that. The best semantic use of accounts is when you have a simple primitive value that you want to give a useful name, such as using my birthday instead of true. This makes programs easy to read. Exactly, the best semantic use of accounts is when you have a simple primitive value that you want to give a useful name, such as using my birthday instead of true. This makes programs easy to read. If you stick to using counts only with primitive values, exactly, if you stick to using counts only with primitive values, you avoid any confusion of reassignment. Okay, if you stick to using counts only with primitive values, you avoid any confusion of reassignment, not allowed versus mutations allowed. That's the safest. Mm, 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 okay. Reassignment versus mutations. So reassignments are not allowed and mutations are allowed. That's the safest way that's the safest and best way to use counts. So if you stick to using counts only with primitive values, you avoid any confusion of reassignment not allowed versus mutations allowed. That's the safest and best way to use counts. Besides var, less, and const, there are other syntactic forms that declare identifiers, variables, in various scope. For example, here, variables inside of functions. Hello Kyle. The identifier hello is created in the outer scope, and it is also automatically associated so that is referenced the bottom. But the name parameter, my name, is created only inside of the function. Exactly. The identifier hello is created in the outer scope or in the global scope. All right? Let's say here in the global scope. and it is also automatically associated so that it references the functions. But the name parameter, my name, is created only inside the function, and thus is only accessible inside that function scope. Exactly. Hello and my name generally behave as var declare. Hello and my name generally declare as var, behave as var, because exactly, since in syntax, since with values we can have now literals and okay, so with values we can have literals, or we can hold them inside of a variables, and we can think of this as a container, and these variables can be declared or created, and it has several syntax that describe the declaration of this, and each one of those has inner different behaviors. So you can think of this like some sort of switch, all right? Each one of those keywords, you can think of this like some sort of switches, right? Where you have a switch to turn on the lights in your bath. You have another switch to turn the lights on your kitchen and the living room, so on and so forth, right? So because of this, each one of those switches, they now behave different and they provide something different, right? So that's interesting here, to look at this. That's yeah, man. So anytime that you see a particular keyword, all right. So for example, let, or cons, or var, which is the way how you can store values. Or the other is now control flows, like if or else, all right. And for looping, when you have now for, or you have while, or you have do while, all right. You have do while this, right? And another is for control flow. So for example, like switch, all right. That's very interesting. So each one of them now provide is a behavior of that, and this is quite silly. This is quite silly. This is quite silly, but there is a reason why it's not that. There is a reason why it's so obvious, because it's not that obvious here. And the other is now functions, right? And the other is now functions, and the other is now class. Yeah, absolutely. The other is a this, and so on and so forth. So it is very important, at least, yeah. This is the reason why actually I'm doing this. All right. Another syntax that declare a variable is a catch clause. It's interesting. Oh, exactly. Okay, exactly. The error is a block scope variable that exists only inside of the catch clause, and they haven't declared with let, as if it has been declared with let. Okay, but here we are with values and string and value determination, declaring and using here is that, right? Because there are various syntaxes to declare variables, each form has a different implied behaviors. So let so let cons and var. So var is a global or function scope, right? Var is a global function scope. Let, I don't know why you have this particular color. Let is a more constrained, is a more restricted. So let is a more restricted of how widespread we want to make a variable available. In this case, only in the block scope, right? Which is var and let, and with cons is a more restricted than, okay, it's in con is similar to lex, similar to let, all right? It's a more restricted since primitive can be since values, exactly, since values can be redeclared exactly, since value can be redeclared or reassigned. However, there is a nuance here. There is a nuance here. And this is the reason why, is because each one of them that you need to understand. You need to understand. You need to understand that. You need to understand. However, there is a nuance here. Because if you stick to using cons only with primitives, you avoid any confusion of reassignment not allowed versus mutation. Exactly. However, there is a nuance and an ill-advised to use cons with objects, since so if you stick to, which is here, if you stick to using cons for primitive, you avoid any confusion. If you stick exactly, if you stick to using cons for primitive, Okay, if you stick to using const for primitive, you avoid any confusion of redeclaration or reassignment. Exactly. You avoid any confusion of reassignment, which is not allowed, and mutation allowed. This is a thing with comes. With comes you exactly if you stick to primitive for primitive values that cannot be exact, and the other is this. Besides var, lets, and const, there are other syntax forms that declare identifiers or variables. And there are other forms to declare identifiers or variables. For example, in the case of functions, hello and my name are both treated as that. The identifier hello is created in the outer scope, and it is also automatically associated so that it references the function. But the name parameter, my name, is created only inside of the functions, and thus is only accessible inside the function scope. But this hello and my name generally behave as var declared. Generally behave as var declare. Exactly, as var declare. And another syntax that declare a variable is a catch clause here in the error. Exactly, and the other is a try and catch block. Try this, and if was any error, notify me this. Functions. The word function has a variety of meaning in programming. For example, in the world of functional programming, functions has a precise mathematical definition and imply a strict set of rules to abide by. In JavaScript, we should consider functions to take a broader meaning of another related term, procedure. In JavaScript, we should consider functions to take a broader meaning of another related term called procedure. And a procedure is a collection of statements that can be invoked one or more times. Maybe provide some inputs and may give back one or more output, but it's a collection of statements. It's an actions. Exactly. It's a calls to actions. It's a calls to actions. It's a call to action. Statement in JavaScript. Mm-hmm. Statements and declarations. JavaScript application consists of a statement with an appropriate syntax. A single statement may span multiple lines. Multiple statements may occur on a single line if each statement is a separate. Mhm. Declaring variables. Mhm. So the word function has a variety of meaning in programming. For example, in the world of functional programming, function has a precise mathematical definition and implies a strict set of rules to abide by. In JavaScript, we should consider functions to take a broader meaning of another related term. But again, I didn't answer the question of statement. What is a statement in JavaScript? Is a unit of code that perform an action or execute a task. Statements are the building block of JavaScript programs, and they tell the JavaScript engine what to do. So here's a key characteristic of type of statement. Basic properties. Statements are executed one after another in sequence. Most again, but this is hmm, hmm. An execution might be, but it's a unit of code that performs an action in what is a unit of code. Provides source of these findings. It was eloquent here. Hmm. Okay. But it's a statements here. A procedure is a collection of statements. Key characteristic of a unit of code: self-contained. It has a clear beginning and end, purposeful. It performs a specific task or represent a concept. Identified. You can point to it and say this is one piece. Functional. Why the terms matter? The concept helps us to think about the co-organization and granularity. When we say a statement is a unit of code, we mean it's one complete instruction that the computer can execute. Mm. Mm. Mm-hmm. 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 Just as you can have small Lego pieces, medium assemblies, and complete structure, code has different size units that combine to create larger programs. I should clarify that my previous explanation about JavaScript statement and unit of code come from my training knowledge of that. Mm-hmm. But again, this is a statement, it's a unit of code. It means that it's a one complete instruction that the computer can execute that. How can I check? Okay. So a statement is a complete uh, instruction. It's a complete instruction that the computer can execute. How can I verify this? These are statements. They execute successfully. This will error in global scope, but it's syntactically complete. Mm-hmm. Use a JavaScript validator and parser. Try tools like browser developer and tool. That's the one-line rule. Generally, if you can write it one line, it makes logical sense to execute it. It is likely to complete a statement like this. Incomplete, needs a body, needs a value. But is this? All of this is complete instructions that the computer can execute. This is when it comes here to this. This is exactly what I'm looking for here. Because you're talking about is functions. Okay? You're talking about here is functions. We're talking about here is functions. That the word function has a variety of meaning in programming. And for example, in the world of functional programming, function has a precise mathematical definition and implies a strict set of rules to abide by. In JavaScript, we should consider functions to take a broader meaning of another related term, procedure. And a procedure is a collection of statements, which is a collection of instructions, unit of instructions that can be executed by the unit of instruction that can be executed, man. And a statement is a complete instructions that the computer can execute, man. It's in the statement is a unit. It's a unit of code. It's a complete instruction that the computer can process. Okay. This is the definition of a statement here. And it all starts with functions. So mathematically, functions is, or in the functional programming, exactly. So in the functional programming, function has a precise mathematical, exactly, the terms of function has a precise mathematical has a precise mathematical definition and implied a strict set of rules to abide by, and imply a strict set of rules to abide by. That's interesting. To abide. I can stand it. I can abide. Okay, to abide. To abide. Rules in plural, to abide. In JavaScript, the term function we should consider the term function, okay, to take a broad meaning of another related term, to take a broad meaning, to take a broader meaning of another related term, to take a broad meaning to another related term. Procedures, which is a collection of statements, unit of codes, unit of code, exactly, unit of code, unit of codes, man, that performs an action or execute a task. Unit of code that perform an action or execute a task. And that performs an action means that it can now, evaluate all of this and yada 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 yada. And the other is or execute a task here. So in JavaScript, we should consider the term functions not as a mathematical not as this strict mathematical definition that define a set of strict rules to abide by, which is the functional programming. But here we can think of functions that also can be described as a procedure, which is a collection of statements that can be invoked one or more times. which is a collection of a statement, this code, this unit of code that can be performed, that perform an actions or execute a task. All right. So which is a collection of a statement that can be invoked one more time, that can be invoked one or more times, maybe provide some input, and may give back output, right? And may give back one or more outputs. So it's not deterministic. That's what it is. So from the early days of JavaScript, function definitions look like this. Mm-hmm. So like this. This is called a function declaration because it appears as a statement by itself, not as an expression in another statement. So for example, like this. This is called a function declaration because exactly. And this is from early days of JavaScript. Functions defined look like this. This is called a function declaration because it appears as a statement by itself, not as an expression in another statement. The association between the identifier of some function and the function value happens during the compile phase of the code, before the code is executed. In contrast to a function declaration statement, in contrast to a function declaration statement, function's definition, this is called a functions declaration. In contrast to functions declarations, a function expressions can be defined and assigned like this. Alright? So this function is an expression that is assigned to a variable. And variables is a container of this. So you contain now this set of instructions here. That's pretty mind-blowing here. So you have now this container that when you call this, it's going to now run all of this set of instructions that you provide. And that's powerful. So this function is an expression that is assigned to a variable awesome functions, and different from the function declaration form. A function expression is not associated with its identifier until the statement during runtime. Okay, different from the function declaration form, a function expression is not associated with its identifier until the statement during runtime. Until that statement during runtime. It is different from different from the function declaration form. A function expression is not associated with its identifier until the statement during runtime. Okay. It's not associated. So this association with the identifier is not done until that statement happens at runtime. It is extremely important to know that in JavaScript, functions are values that can be assigned as shown in this snippet. Okay, it is extremely important to know that in JavaScript, functions are values that can be assigned as shown in these snippets and pass around. Exactly, functions are values that can be assigned, which is another thing, which is another type of values. In fact, JavaScript functions are a special type of objects. Value type. Not all language treat functions as values, but it's essential for a language to support the functional programming pattern as JavaScript does. So this is interesting. This is very, very interesting. So because now functions, because the language now, unlike the functional programming, where a function is a set of mathematical rules that is defined that you have to abide by, here in JavaScript functions we can stretch that, or we should think that also as a procedure. Also as a procedure, we have a broader, you have a broader meaning of another related term. You have a broad meaning here of a function, which is procedure, a collection of statements that may receive some inputs, or maybe provide. Okay, it's a collection of statements that can be invoked one or more times. I don't think I actually asked for anything here. Sí, en Arturo. Voy bajando. Sí, voy bajando. I'll be right back. And we're back. All right. So the thing here is that now functions are also values. Exactly. Now functions are also values. It's a special type of objects. Value type. So not all language treats functions as values. In this case, this language is treating now functions, the set of instructions, as a value. And a value is this unit of information of the program, where the value is the value is this program. Okay, so the value is okay. So the value is the unit of information, and programs use these values, or values is how programs values are how programs maintains the state of the application. Is that right? Right? Values is how programs maintain the state of the application, of the program. Maintain the state. Maintains it is a state. Exactly. Value is how programs maintain it is a state, because values can be as a container, or can be literal. right? So because this functions of the values, that is how programs maintain the state, and you can you can maintain this state whether it's literal or held into a variables that act as a container. And these containers now can be is in these containers has different syntax. Okay, and this container that has different syntax, these are forms of syntax where each one of has their own inherent behaviors, whether it's let and cons and var, and how var is used for global or function scoping. Let is a more constraints of var because it's only available on block scope. And also how now block scope is uh, or how let allow you to redeclare reassign values, not redeclare variables. All right. And in contrast with cons, which is is similar to let but with more constraint, because it doesn't allow you to redeclare or reassign a value, and you must define a value on the declaration. So it is safe to go with cons for primitive, since you avoid is the redeclaration, or since you avoid is the reassignment that is not allowed, and the mutation that is allowed for objects. So that is interesting, because also what we're looking is the other way of how you can is declare or use variables instead of a function, as a parameter or as identifier, right? When you define is a function's declaration, and unlike function expressions, which is a way of how you can actually is store this set of instructions inside of this container, which is pretty mind-blowing. All right. And because of this, all right, so now functions are a special type of objects, all right, that allow us to store this data as it is. So not all language treat functions as value, but it's essential for a language to support the functional programming pattern, as JavaScript does. JavaScript functions can receive parameter input. Exactly. JavaScript functions can receive parameter input. So for example, my name, as it is. In this snippet, my name is called a parameter, which acts as a local variable inside the function. And functions can be defined to receive any number of parameters. Exactly. And functions can be defined to receive any number of parameters. So from none upward as you see fit. Each parameter is assigned the argument value that you pass in that position. Kyle, here, on the call. Functions also can return value using the return keyword. So for example, like this. So var message greeting Kyle, like so. You can only return a single value, but if you have more values to return, you can wrap them into a single object array. Single functions are value. Since functions are value, they can be assigned as property on an object. Exactly. Since functions are values, they can also be assigned as property on objects. So for example, like this, since they are values, Okay, so you're saying that, hey, the greeting, the question and the answer here, the key and the value is this. So the key is the greetings, and the value is now this set of instructions, this function. Mm-hmm. And it is all because you have now this intrinsic nature of the value of a function. In this snippet, reference to the three functions reading questions and answer are included in the object held by what to say. Each function can be called by accessing the property to retrieve the function reference value. Compare this straightforward style of defining functions on an object to the more sophisticated class syntax discussed later in this chapter. There are many varied forms that function takes in JavaScript. We dig into this variation in Appendix A. So many function forms. Mm, mm. Okay. So because functions, it all to describe this function. It all starts with describing is the value here. So what is a value? Exactly. So what is a value? How can we? What is a value? What a value represents? What are the different type of values? Exactly. What? What is a value? What is the different type of values? So string, Boolean, number, BigInt, the type of emptiness, like undefined, null, and symbol for holding privately secrets or valuables that cannot be accessed, so they are unguessable. Uh, but you can use this is to hold some private information inside of that. And also the arrays, which is a special type of objects that you can have is a tuple or a list, where a tuple is this fixed length where each one of those elements can be different, where now a list is a non-fixed length or is a variable length where each one of those elements must be the same type, right? And we also look at the objects, right, which is a more general, it's a key indexed value where functions is a special type of objects. And it is a special type of object is because the nature of the function in itself, that they can be used as a value. So since our arrays is something is a numerically indexed collections of values that can be primitive and also objects and even arrays. So the way of how you can now express this values, whether it's literal or you can held in a variables, is this variables is a way of how you can declare that, and it has several forms that each form has a specific that each form has a specific or inherent behaviors. So for example, like var, let, and cons, and how var is for deciding is how widespread these functions how widespread these functions can be, whether it is in the global or the function scope, whereas let is a more constrained declarations, since it only works on a block scope and it cannot be redeclared. All right, it can be reassigned its value, and count is a way much more constrained, similar to let, where it doesn't allow you to redefine or reassign a value, or redeclare or reassign a value. But there is a nil context, okay? There is an ill advice when using cons for objects, because if you stick to only use cons for primitive, all right, you avoid is the reassignment, which is not which is not allowed, and the mutability, which is allowed, right? So to solve these particular issues, it is important to understand the value that you're holding inside of this variable. And talking about holding these values, so another way of defining is the variable is inside of the functions. There is a parameter or as an identifier of these functions. And if you can also define it as a function expression, and because function here in JavaScript, uh, from the functional programming, which is a strict, is a well-defined, strict set of rules that you must obey to, right? Uh, JavaScript treat these functions as something that is more broad, something that is more broad in its definitions, known as procedures, where procedures is a series of statements or code of units that can be executed, that is exactly that it can be executed by the computer, all right? So these statements, these collections of statements, that can that may receive, so this series of this collection of statements that can be called once or several times, and this might receive is inputs, might receive one or more inputs, and then it might return is one or more output, right? Because functions inside of the JavaScript are treated as values, and this is important for functional programming, which is quite. I don't know why this is it. I don't know why this is important to treat. I don't know. So why, why, why it is important to treat functions as value for functional programming. So if you think about this, so since functional programming focuses on this set of functions that receive one single input, return always the same output, right? Treating function as variable is actually crucial for functional programming because it unlocks powerful programming techniques and power. Here is why. Functions, because it unlocks powerful techniques and patterns here. Because it unlocks these powerful techniques and patterns. And this technique and this how to is something that you can learn of this, but if you don't truly understand that, it's like, and by truly understanding it means this is like, what is the, so what is, why is the values are crucial? So why is values, why treating function as, why treating functions as variables is crucial as a function for functional programming? That's a good question, right? So again, why variables functions? Why variables functions? So why treating functions as values are important for functional programming? So according to you, it's because it unlocks now several patterns and techniques. And I don't know what techniques is or pattern that it unlocks. But what I do know is that patterns and techniques are way of doing things. Okay, our way of doing things, our way of doing things in this context. That's what I know. Their way of doing things in this context. And if the problem that you're trying to solve is computations or calculations, so functional programming, of course, is something that is needed. Mm, 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 mm. So, mm, exactly. So if computation, okay, it'll start with a problem. It'll start with a problem, and the problem is that this, and not, and you when you dive deep into the problems, so nature, I do think that it is true, man. Hmm. So nature ingenuinely hidden the solution of a problem is within the problem. And the problem here is that and the problem here is that it's computation and calculations. So when you do really need computations and calculations, all right, it is important to uh, to use this functional paradigm and to treat functions as values, so you can now hold this, okay, so you can now hold these values as it is, and it is result and it is outcome of this. So for example, the high order function and the function's composition and the dynamic behavior. So for example, like this, right? So stride is aggressive, conservative, and balanced, right? So by doing is this, you say, hey, once I call this, functions are as values allow runtime decisions making about which functions to use. Choose a strategy at runtime. Mm-hmm. So you switch a strategy at runtime. Exactly. Hey, I want to use this. Hey, I want to go with this or this one or that or say so on and so forth. You want to call this, and then this is the data they're gonna pass through. Exactly. Since this give me now is a function, then they're gonna return is that with the data here. Dynamic behavior, abstractions and reusability here. You can create genetic reusable code. Exactly. Abstraction and reusability, eliminating code duplication. Add prefix, add suffix, prefixes users, suffixes users, functional patterns, multiply, double, multiply two, exactly functional patterns. But it unlock this. Exactly. So treating functions as variable, you know, is because it is unlocking all of these techniques. Interesting. Holy fuck. It because it is allowing us to unlock somewhat similar to objects here. It is allowing us to unlock things like this. Mm. Mm-hmm. Exactly. Functions as a first class citizen, we can now store any variables and passing arguments and so on and so forth. Functions store in an array. So you have multiply and the operation. and function passed as an argument. And high order functions, which is something that is quite familiar here. And this high order function is that functions that takes functions as input or return functions. And in this case, when you're doing a map here, you're calling is this operation here. And function composition, add one, double, and a square. Transform x, double square, blah, 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 to do function composition. So if you define each one of those functions as values, then each one of those functions, then you can compose that. This is when the functional, and for example things like Redux and so on and so forth, actually describe that. So this is the reason why functions here are why see functions as values is something that is important for the functional programming, because it's because of the pattern, and it's because the pattern that it log. Okay, it's because the pattern and the techniques that it unlocks, techniques and patterns that as long as you need computations, as long as your problem is computations or calculations, yes, it makes it easy to work with this. It makes it easy to work with these huge collections of data, man. Makes a lot of sense. Comparisons. Making decisions in programs requires comparing values to determine their identity and relation to each other. JavaScript has several mechanisms to enable value comparison. So let's take a closer look at them. So making decisions in programs require comparing values to determine their identity and relationship to each other. And this is not the comparison. Okay, there are many various forms that function takes in JavaScript. We dig in those variations in the appendix A. So many function forms. And then we look at the comparison. Making decisions in programs require comparing values to determine their identity and relationship to each others. And JavaScript has several mechanisms to enable value comparison. So let's take a closer look at them. The equalish. So the equality and the equivalence. The most common comparison in JavaScript programs asks the question, is this X value the same as Y value? And what exactly does the same as really means to JavaScript though? For ergonomic and historical reasons, the meaning is more complicated than the obvious exact identity, sort of matching. Sometimes an equality comparison intends exact matching, but other times, take a moment, but other times an equality comparison and an equivalence comparison. If you're spending any time working and reading about yes, you're certainly seeing the so-called triple equals as a strict equality operator. That seems rather straightforward, right? Surely. Strict means strict, and it is narrow and exact, not exact. Yes, most value participant in the triple equality comparison will fit this exact same intuition. But there's some nuance into this comparison here. There is some nuance in this comparison here. And there are deeper historical and technical reasons for these lies. But that doesn't change the fact that triple equal is not actually strictly equal, strictly exactly equal comparison in the strictest sense. The story gets even more complicated when we consider comparison of object values, non-primitive consider. Exactly, for example, like this, and they're false. What's going on here? It may seem reasonable to assume that an equality check considers the nature of contents of the value. After all, 42 is equal to 42. Consider the actual 42 value and compares it. But when it comes to objects and contents aware comparison is generally referenced to as a structural equality. So JavaScript does not define triple equal as a structural equality for object values. Instead, triple equal use identity equality for object values. In all JavaScript, all object values are held by reference. Okay, I held by reference. See value versus reference in Appendix A. Are assigned and passed by reference. What is Appendix A, bro? There's a lot of things in Appendix A. Values versus reference. And so many functions form. Okay, values versus reference. And coercive conditional comparison. Oh, in Appendix A, okay. Oh, there is Appendix. Appendix B, practice. Practicing comparison. And practicing closure. Now let's practice with closure, chapter 4. Practicing prototype. And in a slot machine. Suggested solution. This is suggested. Okay. But you're talking about here is couple things in the appendix. Value versus reference. In chapter 2, we introduced the two main types of values, primitive and object. But we didn't discuss yet one of the key difference between the two, how these values are assigned and passed around. In many languages, the developer can choose between assigning, passing a value as the value itself, or as a reference to the value. In JavaScript, however, this decision is entirely determined by the kind of values. That surprised a lot of developers from other languages when they start using JavaScript. In JavaScript, this decision is entirely determined by the kind of value. In many languages, the developer can choose between assigning or passing a value as a value itself, or as a reference to the value. In JavaScript, however, this decision is entirely determined by the kind of values. Show me example of this. If this is true, so show me example of this. So in many languages, the developer can choose between assigning or passing a value as the value in itself. This is a major source of confusion for developers coming from language like C++ and C Sharp or Java. Where you can explicitly choose between pass by value and pass because you can explicitly choose by that. You can explicitly choose by that. Okay, you can okay, you're passing by value and then you're passing by reference as a pointer here. Common gotcha for new developers here. You're passing by value and you're passing by reference. The automatic type-based behavior in JavaScript often catches developer off guard because they lose the explicit control they're used to having in other language. Understanding this distinction is crucial to avoid bugs and writing predictable JavaScript code. But again, it's the language in itself. Is the language in itself that is instead of is the language in itself, unlike C, C Sharp, C++, or Java, where you can explicitly choose between pass by value and by reference. Exactly. And that surprised a lot of developers from other languages when they start using JavaScript. So if you assign or pass a value itself, the value is copied. Here is your name variable has a separate copy, but this behavior of assigning and passing a value, it is defined by the values. How these values are assigned and passed around. So like C, where you have in like C++ or Java, you have much more fine control about what is the value that is gonna be passed or passed by value or by reference. So you're gonna copy of that. So here's your name variable has a separate copy of the Kyle string from the value that is stored in my name. That's because the value is a primitive, and primitive values are always assigned and passed values as copies. Exactly, because in computer science, here, in this language, so every time you clone things, what you're doing is just creating a copy of this. What you're doing is just creating a copy of this. Here's how you can prove there is two separate values involved. Var my name call, your name, my name. This is now passed by copy. Alright, and when you rename these my names to Frank, alright, now it is Frank. And since this create now a copy of this, not a reference, your name is Kyle. See how your name wasn't affected by the reassignment of my name to Frank? That's because each variable holds its own copy of the values. By contrast, references are the idea that two or more variables are pointing at the same value. Exactly, in memory, such that the modifying this shared value will be reflected by access via of those reference. In JavaScript, only objects, values, array, object, function, etc. are treated as reference. So if you modify one of their values, then it's going to be reflect in other ones, because the value assigned to my address is an object. Exactly, because the value assigned to my address is an object. Okay, my address and your address has copy of the reference of the single share objects. So an update to one is an update to both. Exactly. So these variables where whole when whole is, yeah, both of this, which whole is objects, and objects are assigned or passed by reference. It is held or assigned by reference. So both of them now point to the same value here. So in this case, my address is pointing to this object, and when you assign here, or when you held or assign here, it's actually now assigning to an object, and this object is assigning by value, not creating a copy of this. So again, JavaScript chooses the value copy versus reference copy behavior based on the value type. Primitives are held by values and objects are held by reference. So primitives are held by values and objects are held by reference. And there is no way to override this in JavaScript in either direction, because it already presents that for you. And there's so many function forms. Recall this snippet of function 2, which is the chapter 2, where we're describing about this function here. Okay. Makes a lot of sense here, especially with JavaScript and so on and so forth. So that'll be all for this video. Take care. Bye bye.